Unit 2, Lesson 5, Literal Equations. Your learning target. Today I will use my knowledge of solving equations so that I can solve a literal equation for a specified variable. We will review inverse operations. Adding is the inverse of subtracting. Subtracting is the inverse of adding. Multiplying is the inverse of dividing. Dividing is the inverse of multiplying. Squaring is the inverse of taking the square root. Square root is the inverse of squaring. One-step equations. Isolate the variable. In a regular equation, on the left, we start with a minus 5 equals 10. So we do the additive inverse, negative 5, which is positive 5. 10 plus 5, which, remember, one side, whatever we do to one side equal sign, we have to do the other side. Result is a equals 15. Now, what if we were dealing with all variables? Well, we first have a minus x equals y. So similar to the a minus 5 equals 10, we will add x to both sides. The reason being, when we add x to both sides of the equal sign, the result is a is isolated, and you have y plus x. Now for this same problem, you could also say a equals x plus y. Because remember, when you add two numbers, the order does not matter. Similarly, with b plus 3 equals 9, again, we're going to subtract 3 from both sides of our equation. And our result, negative 3 and positive 3 cancel each other out. And 9 minus 3 equals 6. So again, we see subtraction property of equality, and then additive inverse, the positive 3 and the negative 3 go away. And I forgot earlier to cross out my other inverses. Now here, we have b plus k equals m. So now we have to, since we're isolating b, we need to subtract k from both sides. Again, subtraction property of equality. And then additive inverse makes the positive k and the negative k go away. So we have a result of b equals m minus k. Now, one-step equations involving multiplication and division. In this case, we see a division problem. C divided by 3 equals 2. We want to isolate the variable c. So therefore, we multiply both sides by 3. 3 is your denominator. And as a result, multiply 2 times 3 as well. The result is c equals 6. Now for a literal equation, no real difference between if you have a variable or a number. In this case, we have c divided by g equals h. So we multiply both sides by the letter g, or our variable g, and as a result, the g's cancel, and c will equal h times g. Or c could also equal g times h. Because remember, when we multiply two values, the order does not matter in the end. Questions so far? If you do, feel free to write your questions down on a piece of paper and then contact Mr. Connors. Another case, we have negative 8 times d equals 64. So the opposite of multiplying by -8 is dividing by -8. So the opposite is opposite of operations, not opposite numbers, because opposite of -8 is +8, but opposite operation of multiplying by -8, we divide by -8. And again, division property of equality. I divide -8d by -8. I also have to divide -64. I mean +64 by -8. And the result, d equals -8. Similarly, you have s times d equals t. So d is the variable we are trying to find by itself. And I think here, unlike this one, the highlight should have been around d for the previous problem. Here, we are highlighting the d. So we divide both sides by the letter s. I know it looks like a 5. And in the end, d equals t divided by s. Again, division property of equality, and we did the multiplicative inverse. Because in the end, s divided by s just gives us a big old 1. And 1d is equal to d. Now we have a two-step equation. In this case, now most times we have the variable before the constant, but sometimes we will put the constant before the variable term. In this case, 6 minus 2y is 10. So we subtract 6 on both sides. So we subtract 6 on both sides. And our result is -2y equals 4. And then we divide both sides by -2. Again, division property of equality and the multiplicative inverse. As a result, y equals -2. Now the literal equation, step 1, we divide both sides. We subtract both sides by 6x. As a result, you have -2y equals 10 minus 6x. Now this part is a little different because we will divide each and every term by -2. So unlike before, for this problem, we'll divide each term by -2. So here, divide each and every term. Because we have 3 total terms. So -2y, +10, and -6x. So this is the case where each and every term gets divided by -2. And then this last part, so here, the first part, the -2's cancel. So you're left with +y equals, now we simplify. 10 divided by -2 is -5. And then -6, remember it was a -6 here, divided by -2. In the end, these negatives both become positive, and the result is 6 divided by 2 is 3, and the x just comes on down for the ride. This next problem, here it says solve for r. Now, what I would do, if you have a highlighter, this may help. Highlight the variable you are trying to solve. Because in the end, that'll tell us what we need to do with each and other part or variable in the original expression, or in this case, equation, since we have an equal sign. So in this case, we're solving for r. So we highlighted the lowercase r, and we have I equals p times r times t. So what we need to do is divide both sides by both p and t. So that's the key. Divide both sides by P and T. Sides by capital P and lowercase t. I'm just going to add that in there so you all see what we did in this step. We divide both sides by both the capital P and the lowercase t. Oops. Let me fix that a little. We'll make this look a little more like an uppercase T. So in the end, what would happen? The P and the T cancel out, and we're just left with R by its lonesome, and I is divided by both P and T. Next one, we're solving for the variable B. Again, highlight the variable you are trying to find. So I wrote it as B times H divided by 2. So now we have 2 times A equals B times H divided by 2. And we're going to multiply both sides by positive 2. So then these 2's cancel out. And you're left with 2 times A equals B times H. And again, you may want to highlight the variable B so you know we are trying to solve for B. You want to get the highlighted variable alone. So now, next step, since we see B is being multiplied by H, the opposite of multiplying by H is dividing by H. So we will need to divide both sides by H. So we're left with B by itself in the very end. And on the other side of the equal sign, we have 2 times A divided by H, but we're going to just leave it as 2 times A all divided by H. I'm going to make my lowercase h look a little more visible. There we go. A few more examples. So if P equals 2 times L plus 2 times W, that's the perimeter of a rectangle, we first subtract 2L from both sides. Then our next step is to divide both sides by positive 2, and the result is P minus 2L divided by 2 is equal to W. Again, I'm going to isolate W. We highlight the W variable. Now, regarding the solve for F, C equals 9/5 F plus 32. So first step, subtract both sides by 32. So we have C minus 32 equals 9/5 times F. And then our next step is since we're multiplying F times 9/5, we need to divide both sides by 5/9. So the inverse of 9/5 is 5/9. So when we multiply a fraction by its inverse, the result is such that we get rid of our fraction. So the 5/9 times 9/5, that just all becomes a big old 1. That becomes a big old 1. And in the end, we really don't even need the 1. So then it just becomes F. And our left side of the equation is 5 times C minus 32 divided by 9. This is an exit ticket. You will answer the question and the